I have a model railway in my loft, a very windy loft today. It's a DCC controlled model railway and it's controlled by an Arduino down here and a little custom motorboard down there. And I have a computer running a piece of software called JMRI that's connected to that Arduino down there through a USB cable, and the JMRI software is the place where I actually control my trains. It gives me interfaces, whether that's through a tablet or through Windows that I can point and click on the screen. That's where I have access to interfaces that will control the trains on the layout. But I don't just have trains on this layout that I want to control. There are also things that, rounded up together, tend to be referred to as accessories. There are turnouts, well, the motors that control the turnouts. There are signals and their LEDs. There are block detectors. There are micro switches. There are infrared sensors that all need to send messages back to that controlling software, JMRI, so that it can bring everything together and make sure that the trains interact properly with all of the accessories. There are really quite a few options available in all the different systems that are available for controlling those accessories. It's possible to do it over DCC, so that everything goes through the DCC bus wires and everything's connected to the DCC bus. And if you have a piece of software or a controller controlling that, the DCC side of things, then everything's done through that. The choice I made when I was deciding how to control all these accessories on the layout was a really quite straightforward, simple and well-established system called CMRI. And CMRI assumes that all of the accessories on my system will only ever have two states, whether they're sensors or turnouts or LEDs, and that's on or off, thrown or closed, binary, 0 or 1. So it's a fairly simple system that sends out zeros and ones that represent different accessories at different addresses, and means that I can stick Arduinos around the layout and they can receive these noughts and ones and they can know what to do with them and turn things on, turn things off, set turnouts thrown, set turnouts closed. And in order to get that CMRI data, those noughts and ones around the loft, I use a communication system called RS485. This is the RS485 dongle that's coming out the back of the PC there, and it sends on those pink and purple cables all of the data out, and then the Arduinos around the loft are connected to those pink and purple cables as they go around, and that's how they all communicate. However, it hasn't always been a smooth ride for me in RS485, and I could put plenty of card links to other videos to underline that. The main problem I have is these Max 485 modules seem to expire quite quickly, and when they go, it can be quite a complicated process because they seem to be able to take other RS485 modules on the bus, on the RS485 bus, out with them, and it can take quite a long time and quite a few of these modules to get it all settled down again. Now that might be an error in cabling that I've made, I don't know, but I've never got to the bottom of it. So I've recently been exploring alternatives to RS485 to see if I can find something a little bit more stable. As it happens, right from when I made this loft reasonably habitable, I've had Ethernet up here. It's a fairly new house, and when it was built I got them to put Cat6 cabling into most of the rooms, although it wasn't in the loft. However, there was a TV aerial up here when I came to convert it into a toy train room. So what I did do, the aerial cable was going down in my office, so I got a bit lucky. I kind of taped some Cat5e cable to the end of the aerial cable, pulled, and luckily the aerial cable came through and the Cat5e cable came through with it, so that's given me Ethernet and internet connectivity up here in the loft. And I've ended up with so many network connected devices up here that I've already got two switches up here, one at each end of the loft, so it is very accessible for Ethernet, Cat5, Cat6. So I think if I am getting rid of RS485, this is where I need to be looking.
There is also, of course, the option of Wi-Fi, and I've got a few Raspberry Pis up here that could act as Wi-Fi routers. My actual kind of house Wi-Fi router is 2 floors below this, so I wouldn't really trust it up here, but it'll be fairly easy to get a repeater up here. Really, because I've got wired Ethernet up here, there isn't much point in that for me, but it's all based on TCP/IP anyway, so I'm going to have a go with Wi-Fi too and see what I can do.
But if I'm going to get this thing on the Ethernet, there are a couple of issues I'm going to need to overcome. The most prominent of which is the Arduino doesn't have an Ethernet socket. There are Ethernet shields available, but they're all designed for the Uno. They might well work on the Mega, but they wouldn't be compatible with this sensor shield, the thing that's got all the pins on the top. So I would be really restricting and changing how I work if I was to buy one of those shields. There are, however, little Ethernet modules available for a relatively reasonable price. I think these were 3 for £21 or something like that. Much more expensive than the RS485 modules, but I'm hoping these will be a little bit less disposable than they were. So you get them, and they just have these pins here which plug into the Arduino. We've got these are the pins for the Mega. It actually has the Mega has, and on the sensor shield and underneath has an ICSP header, which is over there, but I haven't actually found which order the pins in, and they're not labelled. I maybe found one picture that shows you, so it might be quite convenient to be able to plug the Ethernet module into there, and I will have a go. However, these pins are also mapped to pins down here, the 50, 51 and 52, I think. So even if I was to use this ICSP header, I wouldn't be able to use pins 50, 51 and 52 anyway. So actually I thought in the end, what better way of reminding myself that I can't use those pins than to plug stuff into those pins. So I've plugged them into those ones, and the order I've got them in is down here on the left. MISO, M-I-S-O, goes into 50. MOSI, M-O-S-I, goes into 51. SR clock goes into 52. And this SCS by default should go into pin 10, which is up there somewhere. However, all of my Arduinos up in the loft already have pin 10 occupied, and I don't fancy fishing it out and replacing it. So there is an override, so I've plugged SCS into 53 just to take up this, conveniently take up this entire clump, and it just takes a little bit of config, one extra line in the sketch to tell the Arduino to look to pin 53 for that connection. Also, of course, there is ground and 5V, which are just plugged into two of the, or one each of the ground and 5V headers on that little block. My thought immediately then turned to MQTT, which is something I'd seen mentioned, didn't really know anything about, but sort of knew people were using as a communication protocol for devices attached to their layout. So I had a quick Google and came to this page and sort of started to understand what it was about. It's MQTT is a much wider protocol than model railways, but it's a framework in which small internet connected things can communicate either to each other or to a controller or something that's collecting their data. It's used for temperature monitoring and that kind of thing, but it also lends itself to model railways and what I would like to do. So instead of having the whole CMRI thing, we still have this push. So JMRI is aware of this broker, which is a server sat in between JMRI, in my terms, a server sat between JMRI and all of the Arduinos or whatever devices end up there. And the JMRI, when a turnout changes, will publish the fact that turnout changed to this server. And my Arduinos will be what's called subscribed to this server, listening specifically for turnouts and maybe other things too, turnout updates coming from JMRI, and that's called a subscription. They subscribe to that feed, and whenever JMRI pushes an update to say that a turnout or some turnouts have moved, because this
Arduino is subscribed, it receives the messages saying that they've updated, and very similarly to the CMRI transmit. So I think it's worth a little bit of a deeper dive. I'm going to have a go then at setting up a connection in GMRI and see what I can do with MQTT. So I'll create an MQTT profile. It's a brand new empty one. Let's load that one in. Dig this out. So not interested in anything else at the minute. Let's just go straight for MQTT. It's an MQTT connection. That's my only choice there. Now, IP address, this is the address of the server or broker, the kind of the intermediary. And according to the documentation on the JMRI website, I can use a test server provided by Mosquito. And here under additional settings, I don't think there's anything I really need to change. I'm using a server that's free to access. There's no username and password, and it's open to everyone, so I need to be a little bit aware of that. And we then end up with topics. And topics are what allow us to filter and subscribe. They're kind of tags or labels that are applied to data as it's sent to make sure that the right endpoint picks up the data. So I'm going to go, remember, track/turnout/ for turnouts. GMRI can receive updates from sensors as well, so that might end up being useful. Sensor receive topic, because similarly to CMRI, I'm going to want to receive information about when turnouts and lights and outputs change, but I'm also going to want to be able to send it information when sensors change, like block detectors and infrared sensors and micro switches, turnout feedback, all that stuff. So this needs to be two-way, so that's encouraging too. And let's save that. It's probably going to want to restart, isn't it? So let's say restart. And there's nothing much to report, really. I guess the connection's there and it's happy. I now need to set something up to receive any updates that JMRI is sending to this server. Next step is to try to consume any messages that JMRI is sending to MQTT. So I went and got myself an Arduino library and I configured it and I set it off, and I couldn't receive any messages. Now I think it's because the Ethernet setup on this script is only allowing the Arduino access to my local network and not to the internet. And I haven't quite got to the bottom of why, and I think it would at this point be a bit of a waste of time to find out why, because I'm only trying to test to connect to a test server. I don't want to continue using an open unauthenticated test server, and there are plenty of options to set up a server on my local network. They're not very resource consuming, and they will happily sit. I think I'm using JMRI, so I'm bound to be using a Raspberry Pi or a PC or something, and there are versions of MQTT broker servers available for Raspberry Pi and Windows. So I'm very likely to end up, if I could see this working, setting up an MQTT broker on my local network, which will rule out the issue of Arduinos apparently not being able to access the internet. But I would still like to be able to test whether JMRI is actually sending something out. So I'm going to run my test profile, and I'm going to set up a turnout and see if I can communicate over it. So let's call it one T1. Let's create a couple. So there's 1001 and 1002. Let's move those around a bit. Now I have some Mosquito software installed on here, so, and I've practiced the commands. So having created a turnout called with an ID of 1001, I'm going to try to subscribe to it through Mosquito. Oops. And what I'm seeing here is a closed value, and this is promising. And the reason why I'm seeing that is it appears that there is a setting within MQTT to retain the last message sent on a particular topic, which will be very useful, I should think, when it comes to starting up layouts and that kind of thing. That's something I've had problems with in the past. But what I need to see now is if this is responsive, if as I change values within GMRI, those values get reflected here. And there we go. That's again, that's promising. But I have two turnouts, and the second one we're not getting a response on because we're not subscribed to it. We're only subscribed to the first one, so I should be able to, I should imagine, go and subscribe to 1002, and there, yeah, we're getting responses. Now there are also wildcards, so what I could say is, I think, show me all updates to all turnouts, which I think is this. So yeah, I'm getting a few updates here. The problem, of course, is I just try and arrange these so that I'm still seeing updates on the window. The problem here, of course, is I don't know, once I'm subscribed to all of them, I don't know which one is actually moving when I click Throne. So I'm going to have to look into that next. But now I know that JMRI is sending stuff to the broker, I think it's time to set up a broker on my local network and really start looking into how an Arduino will read all of this. So I'm going to try and download a Mosquito server. Basic. This looks good. Eclipse Mosquito seems to be the popular version. So let's go for a 64-bit Windows install. That's quick. And see where that has popped up. There we are. So let's let it run. Go through the setup. Just accept the default and see what happens. That's quick. Something I am going to do, I don't know whether I need to, but just to rule it out, is set up port, open up a port in the firewall for the TCP connections, which are 1883 by default. So I'm going to go in and do that. Very quickly. There's also a tiny bit of config to be done, and in order to do it, I'm going to run Notepad as an administrator. I'm going to go and open the file. It's on the C drive, wherever the C drive is in Windows 10. Promising program files. There should be a Mosquito folder here now. Mosquito, and if we go to look at all files, we have mosquito.conf, and we end up with a big file here, but the vast majority of it isn't actually needed. And I have saved somewhere some very basic settings which can replace all of this, and it's just those two lines there. So it sets the port and it allows anonymous access. Anonymous access, as far as I'm concerned, is fine because it's just on my local area network, and I'm going to be the only person using it. And because I've installed it on my JMRI PC, it's also only going to be running when JMRI is running, but that's fine because I have no other use for it apart from for the layout. So I'm hoping that that is now set, but I need to work out what the IP address is of this computer now. So let's hope this still works. Gives me an IP4 version. Here we are, we're 100.29. So I need to remember that, and I can take this away now and come back here. And I'm going to change the settings on my GMRI profile to use that IP address instead. 192.168.100.29. And I should think I'm still using the old one, so I'm going to reboot this. Now it's not loading, and I think this might be because going back to my PC, I might need to restart the MQTT service. So if I just type services and start, go and find the Mosquito one. Mosquito broker. Let's, oh, in fact, started. It hasn't even started, which doesn't help. But it started now. So my timed out JMRI, I'm going to quit, and I'm going to try again on the right computer. Let's see if this is any quicker. This is quicker, so this is better. It has a connection on this 100.29. Now then, if I get rid of all of this, we're back into, I'm going to try and get this Arduino Sketch working now and connecting to 100.29, although I suppose it would be a good idea to make sure that we're getting something on here. So if I quit this old one and replace this with that, looks like we've subscribed to something. It's probably, well, there are no topics on this server yet, so there's nothing for it to remember, but I'm hoping I'm connected, so it's not going to have any turnouts because I haven't opened the saved settings file. Let's open the settings file. We now have some turnouts, and I would hope that when these turnouts get moved now on MQTT, even though they're in the same profile, we're now publishing to a different server, which is hopefully the local one. So yeah, this is promising. We're getting a response now on this IP address. So it's time now to try and consume this in an Arduino Sketch. I'm going to go right back to the start then and talk through how I got an Arduino that has an Ethernet module attached, working on the Ethernet, talking to that MQTT server. First thing to do is go to libraries, manage libraries, and there we go. And I added the pub sub client library to my Arduino. I tried this Arduino MQTT client and it was okay, even though it just disappeared. But it was it seemed a little bit restrictive in that it would only allow me, it appeared to only allow me one subscription when the script was running, which seemed a little bit too I'm searching through all these. I'm supposed to be searching through the ones that I've got installed, but it seems to me that I'm not, because I certainly don't have all of these installed. I do, however, have this one installed. So this is the MQTT library that I'm actually using, pub sub client by Nick O'Leary. And once it's installed, you get some examples, which is also always a good place to start. So down here, I think let's try the basic one. And it assumes that we use Ethernet, which is good. First thing I'm going to do, now here's a good tip. You'll see here, MAC addresses need to be unique. So if I was to use this example on a number of different Arduinos, I would get communication errors, probably wouldn't get any communication over the Ethernet because everything was using the same MAC address. A MAC address is, at a hardware level, is meant to uniquely identify a node on a network. Some
devices, probably the more expensive Ethernet shields, will come with a MAC address printed on them, but not all of them do. This one certainly doesn't. But the MAC address really doesn't need a hardware value as long as they communicate with them. And I found this resource on the internet, and I'll post this link in the description. It's very useful because every time you refresh it, it gives you a completely random different MAC address, which is exactly what I need. So I'm going to copy that one, and you can just use it. The line it gives you, you can simply use it to replace the one that was there. So let's do that. My IP address here will be 192. These are commas, which gets me 168.100. And 100 will do for this. It doesn't really matter as long as there's nothing else on that IP address. And the server is on this network as well, 192.168.100. And I've ended up using one on 29 because this is my office PC, and the PC in the loft's switched off in a minute. Usually there'd be more here. There'd be a default gateway and a subnet mask. Subnet mask typically isn't really required. It's probably using a default one, and I don't need a default gateway because I'm only communicating on my local network, so I'm hoping that will be enough. I did mention that there's a line that you need to add if you're not using the default pin 10, and it's down here. You need to do it before ethernet.begin, and it is ethernet.init, and then with the pin number that you're using instead for SCS, which for me is 53, and that's all I need to do to make it work. This delay is important after ethernet.begin. There's some talk, I did a bit of research on these network modules. There's some talk, they have a pin for reset, and I can't find a reset pin on the Arduino. It basically means they need to be reset when the Arduino's reset. I found a quite interesting article that said actually you don't need to reset them at all. You just need to put a delay of, the article I read said 250 milliseconds, but I'll leave that at 1.5 seconds because it doesn't really matter. And so that should be it connected. What I might do straight away is I'm not going to publish anything to that server because it's my server and I don't want any topics that I don't understand. But what I will do is just put track, turnout, and for ease, let's just go for all of them. And looking at this, that might do. So the general idea of this this sketch, which I quite like actually, is it nominates when it goes through the loop here. It actually uses a loop function that's in the library somewhere, and when it does that, it actually passes this function here, this void, not reconnect, where's it gone, callback. This callback function will be called every time it receives a message, which I quite like. So if this works, this is where I'd be putting all my, well, change your turnout now and all that kind of thing. Let's just see if this has done enough for it to work. We've got a machine on the port. See if this is any better. There we go. And straight away, that's looking good. We've got the messages that we would expect to see, really. So if I bring up my panel Pro, which is on that MQTT connection, and load the settings in, that's just on the screen, it doesn't matter, and then turnouts, which monitor if they appear, all the way over there. Let's pull that, and again these should be causing a response in the sketch on the Arduino. So we have a very basic, almost library-esque sketch running on the Arduino, and it's still working with Panel Pro. So far this has really been quite straightforward.
I think it's time to give it a little test. And here on my every project, everywhere, all at once kind of workbench, I have an Arduino connected to the Ethernet module, which is connected to a network cable and going off onto my network. I have the Arduino connected to a PWM driver board, which in turn is connected to a few of these servo motors, some of which work and some of which don't. I think this one is on the first pin, and this does work, which is the most important one.
I've had to do a few little modifications to the MQTT client script. I've added the Adafruit stuff in, just copied from that servo's example file. And I've done a little bit of work in the callback function. The callback function is what's called when the MQTT client running on the Arduino detects that a new message has arrived on a topic that it's subscribed to. So this is the one I was looking at before. But it now just does a little bit more work, because we know it's going to get turnout track/turnout/ID. That ID is going to be 1001. So this little bit of code here just turns that message into an ID by picking, where are we? So first thing it does here is gets an integer of the last position of the position in the string of the last /, and then it uses that to go to get the rest of the string after the /. That's that substring bit, so it ends up with the 1001. It turns that into an integer, and then it subtracts 1001 from it. So if I end up with 1001 and I take 1001 off it, I end up with 0, which is the index of the first servo on the PWM board. If I get 1002 and take 1001 off it, I end up with 1, which is the index of the second one. So that's all it's doing. And I think I have somewhere the console, which might be handy as well. The system console, there it is. Let's drag that over to here. And I also need GMRI, which I think I have running as well, the turnouts table. So let's pull this over here too. So let's give it a try and see if it works. Camera set on servo, so we keep an eye on them as well then. So it should just be a case of clicking on these buttons and seeing what happens both in the console window here and down on the bench. That's one that doesn't work, I think, but that one works. And I think there's movement. I can hear something over on the bench. So this is working. I'm getting from GMRI through MQTT, through the broker server, into the Arduino, back into the Sketch, and into the servo. So this is potentially still a replacement for CMRI.
Another advantage as well of MQTT that's become apparent as I've been playing with it is it can and does transfer more than zeros and ones. Remember looking at the screen feeds when I was throwing turnouts, instead of a 0 for closed and a 1 for thrown, I was getting the words closed and thrown. That means it can communicate more than just a 0 and a 1, which is a limitation of CMRI. And I've been playing over the last year or so with RFID, but the reason why I haven't done anything with it and it's all stayed in a drawer is because it's not compatible with CMRI, because RFID needs to send string values that represent the value of the little tag that's crossed a reader, and CMRI is not capable of that because it's limited to binary. But with something like MQTT, and there was already, I saw on the connection screen, a subscription for reporters, which is what GMRI kind of refers to, or certainly RFID falls into the category of reporters. It gives me more scope to include maybe RFID. I don't know whether RFID would actually be of any real value to my layout, but there might be other things I discover in the future that need to communicate with more than a 0 and a 1, and so MQTT gives me the potential to do that. Encouraging signs on the workbench then. I'm quite pleased with how it's going and how accessible and relatively straightforward it's been to implement. But this is still on the workbench, and I think there's going to be a lot of work still involved in actually transitioning this thing away from the workbench and the breadboard and actually onto my layout. For example, JMRI It's very much configured for CMRI. All of my sensors and turnouts are configured on the CMRI interface. How am I going to, if I do get MQTT working acceptably up there, how am I going to shift all existing accessories onto this, onto MQTT? Also, Ethernet for me is very useful, but it still means dragging lots of wires around. So Ethernet and Wi-Fi both sit on TCP/IP, which is kind of what I'm implementing here anyway. So another thing to look at would be how reliable will this be over Wi-Fi? Can I get rid of wires altogether? So still lots of things to look at, but I'm going to keep plugging away at it because I think there really is some value in this.